Integration by substitution. Now, the method of substitution is used to reduce an integral to a standard form. Essentially, that is saying substitution may be used when you get a function to integrate that is not in a format that you know directly how to integrate. In such a case, you can use the method of integration, the method of substitution. Now, when using substitution, we change from one variable, say x, or x, say, to a new variable, u. So literally, whenever we use the method of substitution, let us say we get a function to integrate that is a function in x. When we do a substitution, we literally change this function in x to a function in what of u that we readily know how to integrate. All right, let us see this in action. All right, example 69 says, find the integral of x into the root of 2x plus 1. And of course, we're integrating with respect to x. Using the substitution, u is equal to 2x plus 1. So as we said previously, literally, we're going to replace all x in the integral with u. So I know what that u is equal to 2x plus 1. So wherever I see 2x plus 1 in the integral, I could take it out and put u. X, 2x would be equal to u minus 1 divided by 2. So now I have x is equal to u minus 1 over 2. So anywhere in the integral I see x, I could replace x with u minus 1 divided by 2. The next thing we have to replace is we have to replace the dx. Now, u is equal to 2x plus 1. Now, du by dx is equal to 2. So, next, I'm going to sort of bring this down here and bring the dx up there. I'm going to have du over 2 is equal to dx. So now I'm ready to change my integral to a function in u. So now the integral, which is the integral of x into the root of 2x plus 1 dx may be represented as x, which is x we got to be what? U minus 1 over 2 times the root of 2x plus 1, which is the root of u dx, but dx could be replaced with what? Du over 2. All right, so this 2 multiplied by this 2 here would give me 4. So I could then say that this integral is equal to 1 over 4. So I simply just pull that out of the integral. U minus 1 to u raised to the half power du. All right. Next, I'm going to apply distributive law. So I have my quarter out here. The integral of what? U to the 3 over 2 minus u to the half. And of course, I'm integrating this with respect to u. All right, simply, distributive law says whatever is inside the bracket is multiplied by what is immediately outside the bracket. And your law of indices says that if you're multiplying and the base is the same, you must add the indices. All right. So now I'm ready to integrate because this is now in a format that I know exactly how to deal with. So this would be equal to 1/4 whenever you integrate, I'm going to increase the power by 1. So this is u to the 5 over 2. And then I divide by the new power, which is what? 5 over 2. Alright, again, if I increase the power by 1, it's going to become 3 over 2 plus 1. And remember that 1 is the same as saying 2 over 2. So 3 over 2 plus 2 over 2 is 5 over 2. Minus u to the 3 over 2 divided by the new power, which is what? 3 over 2. And this, of course, plus c, which is the constant of integration. All right. So again, whenever you integrate, you increase the power by 1. So that becomes a half plus 1, which becomes 1.5. Now 1.5 is the same as saying 3 over 2. All right. So let's continue. All right. So let's continue on a new page. So what we have now is that this is equal to a quarter. All right, and dividing by 5 over 2 divided by 5 over 2 is the same as saying multiply by 2 over 5. So this is 2 over 5, and then we have u to the 5 over 2 minus dividing by 3 over 2 is the same as multiply by 2 over 3, and this is u to the 3 over 2 plus c, which is the constant of integration. So this becomes 1/4. All right, and u, if you remember, u is equal to 2x plus 1. So this becomes 1/4 times 2 over 5. U, which is 2x plus 1 raised to the 5 over 2 power minus 1/4 times 2 over 3. So I'm applying distributive law. And this is 2x plus 1 raised to the 3 over 2 power, plus, of course, c, which is the constant of integration. So our final answer is going to become 1 over 10, 2x plus 1 raised to the power 5 over 2 minus 1 over 6, 2x plus 1 raised to the power 3 over 2 plus c, which is the constant of integration. So this is our first example using the method integration by substitution. All right, let's try and see if we can do at least one more example. Example 70, it says find the integral of 3x into the root of 1 minus 2x squared dx using substitution u is equal to 1 minus 2x squared. All right, so we'll start out by saying u is equal to 1 minus 2x squared. Now du by dx would be equal to differentiate 2 times 4, 2 times minus 2 is minus 4, and this is x. All right, so of course when you differentiate 1, you get 0. When you differentiate 2x squared, you get minus 4x. So switching stuff around again, that comes down to the bottom and the dx goes up to the top. I get du over minus 4x is equal to dx. All right, now I will just tell you here, don't worry about remember, whenever we do integration by substitution, we're going to replace all x with what? U's. Now I'm telling you from now, you look out for it, you'll see it. You don't have to worry about that x because that x is going to cancel this x here. All right, so I'll show you that in a second. All right, so I think I'm ready now to write my integral. So the integral of 3x into the root of 1 minus 2x squared with respect to x is the same as the integral of 3x. Remember, 1 minus 2x squared is u. So this is times the root of what? U. And dx, I can replace dx with du over minus 4x. All right, remember, method of substitution, all x's must go. And you can see now that this x here cancels this x, so that goes. So now what we have is what? Minus 3 over 4. That can go outside of the integral. Minus 3 over 4. The integral of the root of u, which is u to the half power, du. All right, so now we're ready to integrate because this is now a standard power integral. So this is minus 3 over what? 4. The power is going to increase by 1. So this becomes what? 3 over 2. When you add 1 to a half, it becomes 3 over 2. Divide by the new power, which is 3 over 2, plus c, which is the constant of integration. So this now becomes minus 3 over 4 multiplied by 2 over 3 u to the 3 over 2 plus c. Dividing by 3 over 2 is the same as saying multiply by 2 over 3. 2 here cancels this 4 2 times. 3 cancels 3 1 time. So our final answer is minus 1/2 u, which is 1 minus 2x squared, all raised to the power of 3 over 2 plus c, the constant of integration. All right, so those are 2 examples. We'll do a few more examples in the videos to follow.